Good morning, and that was Dire Straits' Planet of New Orleans for our opening this morning. And we are looking at interest problems as part of our review today. So this is percents and interest. So you have an idea of where we are looking at some of these problems should you want to participate by going to the internet. I'm going to ask Will to cut to the document cam, and that dropped down on me. Well, let's see if I can just scoot that over. That still will do it. That's what you need. So if you're wanting a URL so that you can access what I'm doing, you go to this address. This is what we had on the board yesterday, and I decided to go ahead and just give you a copy of this on the document cam. That's a little bit easier to read. So if you maybe bookmark this, you can come to 4 separate classes. We have the intro that this hour is. There is a Math 70, which is a course in algebra, beginning algebra. There's a Math 90 that's intermediate algebra, and a stat course. It's our Math 134. So as we come off there, and I just bring up a web page for you to indicate what it'll look like when you do this, just as a reminder. And I'll also comment, there's 24/7 access to this, so it's not restricted to a particular password or anything. You're going to get this web page. That's a splash page, as I call it, and it's not all that readable on the screen for the moment, so let me zoom in. Here is the Math 134. As I said, that is our stat course. As I come down to the bottom, that's our intro course, which is what this lecture is about that you're watching today. And if I come up to the upper right-hand corner, that is the Math 70, which is your beginning algebra. And at the bottom right-hand corner is the intermediate algebra, the Math 90. So in any one of these, coming back over to the Math 10, you click on any one of these, and you get a home page for that particular course. So if I click on Math 10, what I'm going to get is this page, which says it's an Introduction to Mathematics home page. And just again, with the idea of looking at that, let me scroll down the right side of that. And there's some information here that you could use. And if you wanted to see lectures, we haven't talked too much about this. Now, I'm not currently set up for the fall semester. We did a summer session this last summer for the 2006 summer session, and I guess I do have, if you look at where it says 2006 schedule, this last one is the fall schedule. So that is, if I come to that and look at what's there, if you were wanting at any time to look at lectures that are related to what we're doing, these are by weeks. Okay, as we come down, and we are right near the end, I'll just scroll down where we are now, and this is in October, then we're going to, no, still in October for the 9th, I'm going now to week 12, and still coming across there, week 13, we are in week 15, and in week 15, there was the final review 1 was discussed. So you could see full lectures. Those are about 50-minute lectures that you could be watching. So any time you want to see a lecture referencing that, you can. I'm going to reverse where I was. So just for those of you, as we come back to the document cam, if you want to get back to where we were, just hit the back key. This is with Internet Explorer. And that brings me back to what was the home page. Okay, so I'll come out so you can see that. Now on the left side, just to review some of the things that can be done here. There is the syllabus up in the upper left-hand corner. Then there are extra units that we haven't done much with. Then as I scroll down, the review sheets, and then this I want you to be aware of, this is a section on video tutorials. So if I wanted to go to that section, just so you know what's there, I see an alphabet. And this is sort of messed up because I've made this viewing so it reads better. It's not the same resolution you'd have on your computer. And that usually comes out left side alphabet, right side alphabet, not a problem. But if we wanted to look at percents, I would go to the letter P, click on that, and then I get what are basically video clips. So here is a percent common errors, 7 minutes. Percent says common fractions, 3 minutes. Deciding on base, rate, or percentage. That turns out to be a 9-minute one. And then there is, as we scroll down, other links. 3 types of problems that we're going to talk about in a moment. That's 6 minutes. And these are all from preceding lectures. Again, 24/7 access. So just to remind you as we finish up the semester that you can spend time looking at these areas at your leisure. What I want to do is come to the review sheets. So as we come back here, we're at review sheets. And I'm going to click on that. And the review sheets that I'm looking at as I scroll down now, I want to come all the way down to the final review. So I thought I'd start with final review 2. And as I look at that, so I'm just going to click on that and notice there are also answers there. So once you do these problems, if you're wanting to see if you're doing them right, there's an answer sheet. So I click on the final review, number 2. And what this is doing is opening up a PDF file. And I'm going to increase the font so you can see it better. So you'll notice this first problem is something that we've done already as our reviews this week. This is taking a number out of what unit? The counting unit. We're taking a base 6 number and writing it as a base 10 number. Now today we're reviewing percents and simple interest. So I'm going to scroll down until I get to a percent problem. And as I come back to the document cam, there it is. Now this is a problem about percents, and some information is given here. And by the way, what I'm asking you to find will come right there. I want you to find the discount, the sale price, the tax, and the final price. You're going to need a calculator out to do this. So this is discount, sale price, tax, and final price. And by the way, this is a $599.99 stereo for your car. It's under $600 by a penny. Now you look at that and you see 500, and in your head, hey, this is 500. It's 1 penny off of $600. So you have to be cautious. Now the question, what is my discount rate? So let me scroll across. Okay, so we're going to discount it at 20%. That's good. I like that kind of savings. And the question, what is the sales tax? So I'm going to decrease this font just a little bit. And there we can see the sales tax at 7%. So that's a little bit harder to read, so I'll increase back up. So let me just scroll across a little bit more. So there's our 7%. So remember, it's $599.99, discounted at 20%, 7% tax. So what am I asking you to find? The discount, the sale price, the tax, and out the door with your new stereo that you're going to put in your car. $599.99. Okay, so with your calculator, will you find me the answers? I want you to first just write it out for yourself, and then we're going to do it with the calculator. I want you to write out your answers first. So you're finding me the discount, sale price, the tax, and out-the-door price. Okay, you'll probably prefer to use this one, Chris, because that's what I'll be using. Okay, does anybody else need a calculator in here to do this? Okay. So what I'm going to do here in just a moment, coming off there, Will, we've got that information. I'm going to come back to the document cam. Now this is the calculator basically I'm encouraging you to use for problems like this. This is not your friendly scientific calculator. This is just what we call a four-function calculator. It has a divide, multiply, subtract, and if I scroll down just a bit, a plus key. There's the keyboard. So it has a percent key, a memory plus, a memory recall, a square root key. We don't have to use that for what we're doing here. Those are the keys. That's what we're going to be doing. So you should have an answer by now. I'm going to come back so we can see the screen on this. Okay, Will, let's come to there. That's a pretty good looking screen. I'm going to turn this on and I get a 0. So what am I going to enter first? The total price, $599.99. That decimal point is hard to see in the screen, but it's there. Okay, so we're going to multiply by my discount rate, which is times 20, and then I hit the percent key. Now your percent key is up here. Usually in our calculator that I'm using here, it's in the upper left-hand corner. It may not be in yours. How many of you have it in the upper left-hand corner for your percent key? Just one of you. Upper right for some of you. Okay, so it's going to be usually somewhere on the top. I'm going to hit that percent key, and there is my discount. Now my discount is $119.99 and more. But keep in mind that typically the discounts will be rounded down. So my guess is the discount is technically $119.99, not $120. Because discounts will be rounded down. Typically, taxes rounded up. What am I going to do now? I need to know the sale price. So I just found the discount. So I subtract that. So I'm going to hit a minus key and then an equals key. And that is what I now owe for this stereo. $479.99, but I rounded the discount down, so I'll round this up to $480. So my sale price is $480. Now I've got to pay some tax, correct? So I'm going to multiply times my 7% and then hit the percent key again. And so my tax is $33.599. What will I do to the tax? Round it up. So I'm going to pay $33.60 for tax. Now I add the tax. So I'm going to hit the plus key and the equal sign. And so my final price is $513, round this up, 60 cents. So $513.60. Now all you have to do in this problem is write the numbers down as they come across on your calculator. Is there any question there? Okay, Will? And by the way, Will, on that, I put a white background behind the calculator and it made it easier to see the screen. So that was an improvement, I think. Any question in that one? Okay, that's very good. I'm going to come back to the computer here in just a moment. Okay, let's see what we've got here. Remember I asked you in this problem, just to remind you of what I wanted you to find. We found those, right? The discount. So those are the four things that you were supposed to give me. The discount, the sale price, the tax, and the final price. Okay, we can come off there for a moment. Well, I'm going to go back to another review. This is going to be review 1. And as I look at review 1, this is a depressing thought. Now, are you familiar with what IRS represents? It's not independent recreational swimming. This is Internal Revenue Service. Yes. To say friendly IRS might be considered an oxymoron. Frightening IRS is probably more to the point. They're taking $12,000 a year from this worker's wages. How much is that a month? $1,000 a month. So the question, if they take out $12,000, so I'm going, and by the way, I'm wanting to know what here? The gross earnings. Now, what do we mean by gross earnings? What have we used for the word gross in the past? 144, 12 dozen, right? But when I say gross earnings, what do I mean? Before taxes. This is the money you don't get. This is what looks good in paper, but isn't what you actually take home. Let's go back to what we have here. I want you to find what you got before taxes. And just a comment here, the IRS is not the only group taking money from your paycheck. Who else gets money? The state will take some money out. Well, usually the local and the county would come in property tax that you would have for a house. But what else would be taken from here potentially by an employer? If they want you to have medical coverage, they may expect you to pay part of it. You might have a retirement account that you have money taken from. So $1,000 may just be the beginning. Maybe they're taking $1,500 out of your account before you get your check. So this is just the tip of the iceberg, but a big iceberg it is. Let's go back to the document. Cam, I'm going to scroll across and let's see at what rate the money is being taken. And by the way, that may be a little bit numbing. This problem is saying that the IRS is going to take out 25%. Is that high? Low? Well, if you make enough money, it may be 30%. If you go to some other countries, it may be 50%.
Where does it go?
Well, the money, the question is, where does it go? Well, ideally, to keep your roads repaired and in good shape, and to provide you for homeland security so you feel safe. And on a local level, state level, certainly it covers things like fire protection, police protection. So taxes keep us doing some good things. Taxes also get spent for what? Well, we pay taxes sometimes for wars. So a lot of the tax money that's going out is being used to finance conflicts. And we sometimes don't take enough money from you as a federal government. And so we have a deficit, and we talked about our deficit, and it was up in the what?
Trillions.
The trillions. So the fact that we take out 25, 30% should not make you feel that you're doing enough, because otherwise we wouldn't have this $75+ trillion that we owe as a deficit. Okay, with enough tongue-in-cheek, how do you find your salary before taxes? Okay, so we need some way of doing that, right? So we're going to use our triangle to help us see what to do. So let me go to the board with the triangle. And just sketching that freehand, something like this, correct? And so down here we put the whole, which is also known as the base of the mountain, and the percent over here on the right, and then we have the peak of the mountain with part of up here, and sometimes called the percentage. I put a times here because if they're on the same row, we multiply. And if they're what? One over the other, we have a divide symbol. So that's our triangle. And that's what we're using. Now, in this triangle, your most difficult task when you're given one number is to decide whether it's the part or the whole. Well, I know, but how do you decide that? I know that we need to find the whole. But how do you make that decision? And part of it is knowing what the words mean. So if I tell you that there's $12,000 in tax, you know the tax isn't everything. It's just a part of what you pay. But if I told you that you earn $12,000, otherwise you're working part-time going to school, and you earn $12,000 for the year, $1,000 a month, that'll certainly keep you in gasoline for your car if you don't drive very far, and maybe give you some opportunity to do some entertainment and so on. But if it's $12,000 a year, it's a whole if that's what you're living on. If this is the tax that's taken out, then it's the part. And there's no rule of thumb there. You have to read the problem and make a decision. Okay, so we have a part. That's up here. And we also have a percent, correct? So I have a part and a percent. What don't I have?
Whole.
The whole. So if I cover up this, then I'm left with part divided by percent. So I'm going to write that the whole, and this is where I talk to you about formula, substitution, and answer. So the whole is the part over the what? The percent. That came from my triangle. Formula, then substitution. So the substitution, I had a $12,000 tax, and my percent was what? 25%, but I'm going to change it to a decimal. And when you do that, you should find $48,000. So the point is, you made $4,000 a month, but you only saw $3,000 a month. Well, you didn't see that much because the IRS was taking $1,000 a month, and then there are a lot of other deductions in your paycheck, so you might be lucky to see $2,500. So roughly, you're living on what? $2,000 a month. $2,000 a month for 12 months would be $24,000. So you are living on half of what you earned. Okay? That's depressing. But think of all the things you get because of it. Okay? Any questions on that one? Just depression. Okay, let's do another problem. What I'm going to do is first, I'm going to come back to that and just show you what the answer section looks like there. Give me a moment to get there. Here's the way I had it presented. I don't want to, yeah, that'll work. Okay. I had it done that way. Now notice the only difference with what I have there, I did 25% in the denominator instead of what? 0.25. You can write it either way for your documentation. Just be careful. So you can use your calculator to help you with the percent key, or you can just go to a decimal. So let's go to another review. Let's see what we have for the third review in this. Let me first check and see what it is. Okay, let's see what I want to do here. Well, I'm going to increase the font size rather than anything else. Get this large enough so we can read. Okay, that maybe is a little bit too large. Let's see it 150%. Maybe that'll work. Okay, we've got a store advertising. That doesn't read big enough, does it? So a store advertises that you save $75. Aren't you lucky? And their discount was 33 1/3%. what did you pay for the item? Same formula, right? What's your answer? $225. It is $225. Now let me look at that problem. Again, it's the same answer, same structure, same formula. Whole is part over percent, and the part we saved was 75, correct? $33 1/3%, right? As a common fraction is 1/3. So if I'm taking 75 divided by 1/3, invert and multiply, and the answer is 75 times 3, which is $225. Now, what else could you have done? You could have said that I have 75 divided by 0.333333. And how many threes do you go? Fill up your calculator keyboard screen. And when you do, you should get 225. You might find yourself getting 224.99999 or something like that if you don't use enough threes here. Ah, I was thinking incorrectly because this is always going to be what? Smaller than it should be. So this is a case where you won't get something under, you'll get something over. So you might get 225.000001 because this should have threes forever.
What I did on the calculator was I put $75 divided by 33 and then I put percent key and I gave it.
But 33% you can't do that. You have to do, otherwise what Adrian's saying, you entered 75, then you hit divide by, and then you hit 33, correct? And then hit the equal sign, percent key, and then the equal sign. But what was your discount? 33%, not 33 1/3%. So what I would have done is enter 33 and then have what? As many threes as I can, and then hit the percent key, and then you should get this same amount somewhere around 225 or 225 with a lot of zeros and a 1. Okay?
Yeah.
Do we have any question there? Okay, let's try a different kind of problem. So far, we've ended up with the same style of problem, correct? So what I'm going to do is come back to the percent reviews themselves. They're alphabetical, and let's see what I can get there just looking at one of these. Okay.
Number 8 and 9
Now what I'm going to do is this problem, as soon as I get it in just a moment, I lost where the problem is I want. There we go. I don't know if you've ever coached. A lot of parents do. Coach a soccer team, a baseball team, football team. So here's a problem. A coach buys a new stopwatch. Now sales tax is 6%. Now we pay what? 7, we pay 7 plus. And some counties you pay as much as 8% or higher. So this is a mythical county. 6% tax. Buys a stopwatch. And we are told that it sells for $75. So if it sells for $75, the question is how much tax should the coach pay, or does the coach pay? We are going to assume that the coach is indeed paying tax. 6% for tax. And yes, you would get the number you gave. I agree. No, 4. Okay, so at this point, how do you set it up? What are you missing? You're missing the part. So if we come back to our diagram, we're hunting for the part. bring that so I can see it just a little bit tighter? Okay, I'm hunting for the part, and the part says I'm supposed to do what? Multiply the whole times the percent. Now it sells for $75, so that's the whole, and what is my tax rate? 6%. So as we come back to the document cam, and I write out my documentation for this, this time I'm going to write that the part is equal to the whole times the percent. So we go to the board now. So I've written my documentation. My substitution is what? The $75 for the whole. Now what would you recommend, writing 6% or the decimal? It's up to you, but don't mix them up. In this sense, don't put 0.06 and then a percent sign. So we multiply 75 times 0.06, and this is going to come out $4.50. So $4.50. Yes? Question?
I wrote it part of equals percent times whole.
You can write part of equals percent times whole. The reason I did whole times percent, because my triangle typically has whole on the left bottom, percent on the right bottom, and I'm just writing them in the order I see it there. Doesn't matter. Multiplication can be reversed. Call that commutativity. And so we have the same answer either way. Is there any question there? Okay, there are a number of problems that we could do with interest. We've done two of the types. What's the third type? We found the part, and we found the whole. What's another type of problem? There's three of them. There are three of them, where we're hunting for percent, correct? So let me get a problem where we're doing that. And let's see what I can do. Okay, I don't like that particular review, so let me come back to the third one and see if I can find a better result for a different. Okay, let me increase the size of this. There we go. Now, a student takes a test. It's a 45-question test. And the way that's stated is that 35 problems were correct. And of course, what's wanted here is the percent correct. And if I go much further, I'm going to lose the two numbers I need. So 35 out of 45, what is your percent? That's the question. What percent did you get in the test? So I'll let you do that one for a moment. We'll leave that on the screen. Okay, again, giving you time to do that on your own. Remember the documentation. I want the formula, substitution, and answer. Okay, so now we can go to the board, Will. The formula for percent. Well, you see part of at the top over the whole. Now, as I come back to the document cam, you have to understand that the 35 is the part of the whole you get right. So my substitution here is, so we come back, 35 over 45. Now this happens to reduce. I need it as a percent. But if you reduce this, 5 will go into the numerator and the denominator, giving you 7 over 9. And if you have a number over 9, what's the shortcut? 3 over 9 is 1/3. It gives you 3's forever. 6 over 9 gives you 6's forever. So 7 over 9 gives me 7's forever. The last one I can just write as 7/9. Because 7's just keep going. But that's a decimal, so what's my percent? 77 and 7/9%. If you just wrote 77%, I wouldn't give you full credit. because you're missing nearly 1 more percent. Now, if it was your test grade, you would have asked it the other way. Are you going to round up to 78? Right?
So if we round it up, it'd be okay?
You could round up to the nearest percent at 78%. I'm going to encourage that you round off to the nearest tenth of a percent. Since these 7s keep coming, I would argue that this is 77.8% would be the better answer. I'm a little bit reluctant to round off to the nearest percent. Remember, you have 7s forever. So rounding off to the 10th.
And we'll get full credit for 77.8%?
Yes. Yes, you get full credit for that.
Okay.
Okay? So 3 different types of problems. One where you're solving for percent. One where you're solving for the whole. And another where you're solving for the part. Okay, I'm going to go back center. This is the holiday season, correct? Now, what kinds of things do we do in the holiday season around Christmas time? Spend. That's sometimes a somewhat cynical view, but the retailers really like it. Spend, spend, spend. You start the Friday after Thanksgiving and keep on spending until Christmas Eve. And they'll appreciate it. Let's say you've gone shopping and you see something that you want. That's sometimes the most fun. You're shopping for somebody else to say, oh, I'd like that. And take care of you first. Okay, $1,000 purchase on your credit card. 18% interest rate. What is your bill the first month? That's my question for a test problem. You charged $1,000. You did it on a credit card that has an 18% interest rate. I want to know what your bill is for that first month. See, you bought this in the first of the month and you left it under the tree until Christmas Day. So how much does it cost you for that month to leave it under the tree for a month? Storage fee. What's my formula that I have to use? I'm going to use the right part up here. What's my formula to solve this problem?
$1,000 times.
I want the formula. No numbers yet. I have a very special formula I have to use. It's a shampoo. Pert. Well, we leave the E out, but you get pert. So I'm going to go up to the right-hand corner. PRT, little I, equals PRT. Principal, your interest rate, and your time. So if I charged a $1,000 item, then I have equals 1,000. My interest rate is what? 18%, so that's 0.18.
Divided by 12.
But I'm only buying it for the month. If I pay it off, it's over. So I'm going to divide by the 12 because it's only for the month that I'm paying. Now, if you say, well, wait a minute. I thought you said times. Well, times 1/12 is the same as dividing by 12. What do you get? I agree. So $15 to put it under the tree for the month. So, coming back to center, my question, what is your bill? You charged $1,000. They put $15 interest on it, correct? So they're going to bill you for $1,015.
Unless you pay them before the
Okay, if you pay it before the month is up, I don't know if they charge you then or not. If you paid it no interest, if you get your bill, they don't have any interest on it in that first month? Okay, pay it then. Now, if I had 1,015, how much would I pay minimum payment? Minimum payment is typically what percent? 10%. So that could be a percent problem. So as I go back to the board, I look at my bill, which is, so my bill for this charge is 1,015. So that's what I see on the bill when I open it. If I'm paying 10% minimum payment, then I multiply this by 10%. Now the equivalent of that is to do what? Move the decimal one place to the left. So I'm actually paying $101.50 in that first month. Now does that, well, in the first month that's not a bad idea. What I'm going to do, Will, is take another camera in a moment. I'm going to go back center here for just a moment. And what we're going to do is look at a payoff table we have. So if you'll bring camera 2 to the side, I have this set up so you can see the payoff table. So we'll go to camera 2 in just a moment. And whenever you're ready, go into that if you would, please, Will. Okay, there's my payoff table. There's my 1,015, and I paid $101.50. And then I have a new balance, correct? So my new balance just does a subtraction. You can check this out on your calculator. Okay? So you're going to take the 101.50 from the 1,015, and here's what you owe. $913.50. That's your balance. You've made your payment. Now you multiply this $913.50 by the 0.18 and divide by 12 again, and that gives you $13.71, rounding the interest up. So remember, typically you'll round interest up if you owe it. Rounded it down if you're given interest. This comes out at $13.71. So I add that on to what? So I'm adding it on to the balance I had, and my new bill is $927.21. So if I owe $927.21 and I'm going to pay a 10% each month, all I do is move the decimal one place to the left, and I'm rounding up to make sure that they get their 10%. Otherwise, it's just under. So it's $92.73 that I pay. Again, a question for you. Notice my payment's going down each month. Will I have this paid off at the end of a year? No. If I pay 10%, roughly $300 I'll still owe next Christmas on last Christmas. So what do you do instead? What's the recommendation? Take that $101.50 and you make that payment every month and don't charge anything else. You bought the one gift, that's it. Tough love. We got it? Now let's say at the end of the holidays, and you could carry this on line after line. This is just a payoff table, correct? So let me come back to another problem in the simple interest unit. Let's slide over now, Will. It's January 1. Somebody was really nice to you, and they gave you $1,000. Now you have a choice. Spend it or invest it. And one response is, spend it. How about invest it? I'm going to put it into a certificate of deposit that's going to get 4%. So I'm going to invest in a CD. This is not the CD you listen to. This is the CD you invest in, a certificate of deposit, at 4% interest, compounded quarterly. So my question, if you, instead of spending it, invest it, how much next Christmas in a year? What do you have in the bank? Now that's my question. What do you have in the bank a year from now? So we're going to use the calculator to do this again. So let me come back off. Give me a moment to do that. Back to the calculator. And closing down one of the machines up here. Why did I give you 4%? Any idea? Why was I nice to you? Why was 4% a really nice number to give you? Because what? Yes, it works out nicely. In what way does it work out nicely? You are correct. What do I have to divide by to get quarterly compounding? 4. That's why the 4%. Let's go to the calculator, Will. I'm going to put my 0.04 in there. So 0.04. I have to turn it on first, then it will work better. 0.04. Then I'm going to divide by what?
4.
My 4, because I'm compounding 4 times a year. And that gives me 0.01. The shortcut was to then add 1. Now that's the number I want. And what am I going to do with that number? Put it into M plus first. Store it. So I'm putting it M plus. So I have 1.01 times memory recall equals times memory recall. That's the third time. Times memory recall. There's my fourth. So I have this number, 1.040604. So what I did, coming to the board, I took 1.01 and I just raised that to the 4th power. So that means I did 1.01 times 1.01. This was my first memory recall. Times 1.01, another memory recall. Times 1.01, another memory recall. That's 1.01 multiplied together as a factor 4 times. Back to the calculator. That becomes 1.040604. What am I going to do with that number? Multiply by 1,000. That's what I invested. So that moves the decimal 3 places to the right. Agreed? So if I move it 3 places to the right, it comes over here. So I have 1040.60. So next Christmas, I now have $1,040.60 in the bank. And I could just leave it there for 40 years. So if I left it there for 40 years, so you're 20 when you start this, between 20 or 25, and you leave that money in the bank you invested for 40 years, how does the problem change? Well, for 40 years, I take 40 times 4, because I do it 4 times a year, that's 160. So I have to put 1.01 to the 160th power times 1,000. So let's just, out of curiosity, see what you'd have 40 years from now if you did this. Now to do that problem, I'm going to have to use a different calculator because I don't want to go ahead and do this using a key that I hit 160 times. I don't want to have to hit memory recall 160 times. So this is the $11 calculator that used to run $250 30 years ago. So this is at $11. It's at our bookstore. Again, I'm going to turn it on. And this time I have to use what is called a y to the x key. That's this key right here. So for example, if I want to do what I'm doing here, I want 1.01 y to the x, and I'm going to do 160. This is how fast that goes. And so I have 4913. So let me write that number. We're nearly done. So I'm going to write 491386, and I'm going to multiply that by $1,000. Move it over 3, correct? So I have what? $4,913.82 at the end of what? The 40 years. So I went from 1,000 to 5,000 roughly, 5 times as much. Now if I keep putting money in the bank each year for 40 years, I'm going to have a huge amount of money. Okay, Will, we're going to have a test tomorrow. On the test, I've agreed with you. If you haven't checked with me, make sure you do after class so I can tell you which test you're retaking tomorrow. And then we have the final next week. And that's going to be at 10 o'clock for you on Monday. So, Will, we go back to Dire Straits.